So, in the previous lecture of the Newton's laws of motion, I have explained these things. It's clear. You can see fundamental forces found in nature, then contact force, non-contact force. It's clear. Then there is one constant force, variable force, like these things I have explained. Then units of force. Though about the units of force you have already studied in the class 10th. But here I am once again going to explain about the unit of force. So see here what are the units of the force. One is the MKS unit. As you know that what is the formula of force? Force equals to mass into acceleration. So what is the unit of force? Unit of force MKS unit will be mass की unit kilogram and acceleration is meter per second square, kilogram meter per second square. What will be the CGS unit? MKS unit. Now in SI system what will be the unit? So in SI system what will be the unit? It is Newton. And as we know that SI unit and MKS unit both are equivalent, means 1 Newton equals to how much? It is 1 kilogram meter per second square. Then there is one CGS unit. What is the CGS unit? If you see, it is meter, mass की unit is gram, acceleration unit centimeter per second square, and we also call it as dyne. 1 dyne equals to 1 gram centimeter per second square. It is clear. Now what is the relation between Newton and dyne? So that also I will explain. You can see here 1 Newton equals to 1 kilogram into 1 meter per second square. It is clear. Now 1 kilogram you can write 1000 gram, and 1 meter per second square 100 centimeter per second square. So that will be 10 to the power 5 gram centimeter per second square, that is equals to 10 to the power 5 dyne. It is clear. Now there are some gravitational units. Weight, you all of you see here, weight, it is also the force, and this we know that it is the force of gravity. It is the force which earth exerts on any body. It is clear. And what is its value? If the mass of the body is m, then what will be its weight? It will be m into g. So there are some gravitational units of force. Gravitational unit of weight. And what are those? So gravitational unit of force is kilogram force. In case of weight, we call it as kilogram weight. And 1 kilogram force is equal to how many Newton? 1 kilogram weight is equal to how many Newton? So you multiply with this with the value of g. G is the acceleration due to gravity, that is g Newton. It will be equal to g Newton. Here approximately I have taken the value of g in MKS system, 10 meter per second square. So what will be 15 kilogram weight? 15 kilogram weight will be 15 into 10, that is equal to 150 Newton. It is clear. 15 kilogram force will be equal to 150 Newton. Similarly, in CGS system, it is gram force or gram weight. And 1 gram force or 1 gram weight is equal to how many? It is equal to g dyne. and here we will take the value of G in CGS system. In CGS system, it is 980 centimeter per second square, nearly 1000 centimeter per second square. So in the same way you can change. Now here there is one very important point. If the in some numerical weight has been asked, then it will not be written in Newton. It will not be given in the dyne. It will be given in kilogram weight. It's clear. It is necessary to express the weight in kilogram weight. It's clear. You will not say that the weight of any object is 10 kilogram. It is 10 kilogram weight. It is clear. So weight is always found in kilogram weight, written in kilogram weight. Now today I am going to begin inertia. What is inertia? Inertia is that inherent property of every body by virtue of which it opposes any change in state of rest or of uniform motion on a straight line by its own. It is clear. What is inertia? Let me erase this. So see here. What is inertia? It is that inherent property of every body by virtue of which it opposes any change in its state of rest or of uniform motion along a straight line by their own. Means no body can change its state of rest. Suppose body is at rest. Suppose body is moving with a certain velocity. So no body can change its state by its own. It's clear. It cannot change its state by its own. It's clear. In order to change the state, what is needed? Force will be needed. Its state will be changed only when you will apply the force on the body. So in other way we can say that it opposes to the external force. It opposes to the external force because of the by virtue of inertia, body opposes to the external force up to a certain extent. It's clear. And what is that extent? That extent is decided by the mass of the body. Greater the mass of the body, greater will be the inertia. Greater will be the inertia means greater will be the opposition towards the external force, because external force demands change in the state. External force is demanding change in the state. When you are applying external force on the body, then what will happen? This external force will try to bring it in the motion. When you will apply the external force here, what will happen? External force will try to change its velocity. But in the beginning, what will happen? Body will oppose to this external force by virtue of inertia. It is clear. And that inertia depends upon the mass of the body. Greater the mass of the body, greater will be the inertia. Now there are three types of inertia: inertia of rest, inertia of motion, inertia of direction. Now what is inertia of rest? It is the inability of any body by virtue of which it opposes any change in its state of rest by its own. It is clear. In the similar way, we can say that inertia of motion, it is the inability of any body by virtue of which it opposes any change in its state of motion by its own. What is the inertia of direction? It is the inability of any body by virtue of which it opposes any change in its state of in its direction of motion. It's clear. So it is that inability. Now there are some examples of the inertia of rest, inertia of motion. For example, when a hanging carpet is beaten, then because of the inertia of rest, dust particles are removed. Because when you will beat the carpet, what will happen? Carpet will move forward. Carpet will move forward. But the dust particles which are settled inside the pores of the carpet, they will be left behind, and due to the gravity they will fall in the downward direction. Due to the gravity they will fall in the downward direction. Similarly, if you are standing on a bus, it's clear, and if bus suddenly moves, then what will happen? You will fall in the bus suddenly moves, then what will happen? You will fall in the backward direction. Why? Because of the inertia of rest. Because when the bus moves, your lower portion of the body, it will come immediately into the motion, but the upper portion which was earlier at rest, it will it will try to remain at rest. It will try to remain at rest. Therefore what will happen? It will fall back in the, because नीचे वाला पोर्शन पहले मूव कर गया, ऊपर वाला पोर्शन 10 मिलीसेकंड बाद मूव करना शुरू किया, सो इट विल फॉल बैक. इट्स क्लियर. Means the passenger will fall back. Similarly, inertia of motion. If you jump out from the moving train, when you jump out from the moving train, then what will happen? You will fall. You are standing here. As long as you are here, what will be your speed? Your speed is equal to the speed of the train. But when you will jump out, what will happen? Your lower portion will come immediately at rest, but the upper portion is still moving with the same velocity. Therefore you will fall in the forward direction. So these are the examples. Through these examples you can go through the examples which are given in your book. It's clear. Then there is one term, momentum. What is linear momentum? It is the total motion contained in any moving body. Total motion contained in any moving body depend upon what? It depend upon the mass of the body, and it depend upon the velocity of the body. And this you can experience from this example. Suppose there is a bicycle which is moving with 1 meter per second. There is a truck which is moving with 1 meter per second. Both are having the speed 1 meter per second. This is also having 1 meter per second. What will happen if you try to stop both cycle and truck? Then you will be able to stop the cycle by standing in front of the cycle and holding its handle. But in case of truck, it is not possible that you stand in front of it and by your hands you apply a force. You will not be able to stop the truck. It means truck is containing more motion than the cycle, though both are moving with the same speed. So how much is the motion contained in any body? It not only depend on the velocity, it also depend upon the mass. So what is linear momentum? Linear momentum of a moving body defined as the total motion contained in any moving body, and it is numerically equal to what? Product of mass and velocity. What will be the direction of momentum? Direction of momentum will be same as the direction of velocity. What will be the unit? See here, unit of mass is kilogram, unit of velocity is meter per second, so it is kilogram meter per second. Now change in momentum. You see what is the change in momentum? Change in momentum means final momentum minus initial momentum, means m into vector v minus m into vector u. Suppose there is any body of mass m traveling with the velocity u. After certain time its velocity becomes vector v. So what will be the change in momentum? Final momentum is m into vector v, initial momentum m into vector v u. So m into vector v minus m into vector u. This will be the change in momentum. It's clear. If the motion is along the same line, then you can simply write delta p equals to m into v minus u. No need to keep the arrow if the motion is along the same line. But here, if you are taking this direction as plus, then opposite direction you will take minus. It's clear. You can see from one example. Suppose there is a body of 10 gram moving with a 10 meter per second. This is a wall, it collides with the wall, and after colliding the wall, it moves in this direction with 10 meter per second. Mass will remain same. It is clear. So what will be the final momentum and what will be the initial momentum? If you take this direction positive, then this direction will be negative. So see here, what is the initial momentum? M into V, that is 10 upon 1000. Initial velocity is 10, that is 0.1 kilogram meter per second. This is the initial momentum. In what direction? In this direction. Now what is the final momentum? Final momentum is in this direction, that is in opposite direction. So that's why we will take the velocity negative. So it will come out 10 upon 1000, negative sign of velocity is kept here, into 10. So it will be minus 0.1 kg meter per second. So what will be the change in momentum? Change in momentum equals to final minus initial, means this minus this. So it will be minus 0.2 kg meter per second. Means what will you say? What is the change in momentum of this wall? It is equal to this much. In what direction? Away from the wall. Away from the wall. It is clear. So this way you can find if the motion is along the same direction. And if it is like this way, here this is the wall, ball comes this way, and after striking to the wall it goes in this direction, then we can find only by using this vector method. It's clear. So this is momentum is what? It is the total motion contained that I have told. Now what is change in momentum? Usually momentum changes because of the change in velocity. But sometimes there may be the change in mass also during the motion. But the change in mass is observed only when the body is moving with a very great velocity. Very great velocity means its velocity is more than 10 to the power 6 meter per second. In that case, what will happen? Its huge energy will be converted into, will induce some mass. Induces mass. Body is already having mass because of what? Because of matter. Body is already having mass because of the matter, which is the permanent mass. But here some additional mass will be induced because of the huge amount of kinetic energy associated with that body. So due to that, what will happen? Its total mass will be now increased. And when mass will be increased, what will happen? Momentum may also change because of the change in mass. But this will be observed only when body is moving with a very great velocity. If the velocity of the body is small, means it is 1000 meter per second, 10,000 meter per second, 1 lakh meter per second, what will be? It is smaller than this or less than equal to this, what will happen? There will be no significant change in the mass. No significant mass will be induced. We will ignore this increase in mass. It's clear? So for present chapter we will take the change in momentum only because of change in velocity. Now what is the rate of change of velocity? Rate of change of velocity is the change in velocity per unit time. No, not rate of change of velocity, rate of change of momentum. What is rate of change of momentum? Change in momentum per unit time. If in the time interval delta t momentum changes by delta p, then what will be the rate? Rate of change of momentum will be delta p upon delta t. So now after this we will begin the Newton's laws of motion. It's clear? From hereafter we will begin the Newton's laws of motion. You will study about the inertia of rest, inertia of motion, inertia of direction given in your book on page number 255. It's clear? That you can read, that you have also studied in the lower classes. So now in the next lecture we will do all the three laws.